In problem number 1, we're trying to find the volume of the largest open box that can be made from a piece of cardboard 2 feet square by cutting equal squares from the corners and turning up the sides. So this is going to be 2 feet, and this is going to be 2 feet. And what's happening, we have a full piece of cardboard, and then these little corners are getting cut out and removed. And these sides right here, see the dotted lines, that's getting folded up, and we're going to make a little open-topped box. So like this side right here would be this side. And this side right here folds up to this. This one would be this side, this one would be in the back. So actually, I guess if it's open, it would look a little bit more like that. All right, so we're trying to find the largest volume. So we're trying to maximize the volume. Right, so we need to write an equation for volume in terms of one variable. So it looks like we're going to use x for this shape right here, this prism, rectangular prism. So these little corners are x, the whole thing is 2. So if we look at this little portion of the box, that would be the same as this right here. That's going to be 2, the whole thing is 2, minus 2x. Right? The length of that side is 2 minus 2x because we're taking off x from each corner. Same thing's going to happen right here. This side right here is 2 minus 2x. And then our height right here is just going to be this side when it gets folded up, or this side, either way you want to look at it, that's going to be x. So the volume of a prism, remember, is length times width times height. We have those measurements, expressions for each of those in terms of x. So we're going to have 2 minus 2x times 2 minus 2x times x. Or one way we could write it instead is just having, I'm going to put the x in front, times 2 minus 2x squared. So we have our volume equation in terms of just one variable. Once we have that, to maximize, remember we have to find the derivative, find the critical value, and check to see where we have a maximum. So our derivative here, we're going to have to use product rule, or we could just multiply this out. I'm just going to go ahead and do product rule though. Derivative of the first term is just 1 times the second term, so 2 minus 2x squared, plus the regular first term times the derivative of the second one. So here we're going to multiply by 2 times 2 minus 2x to the first, times the derivative of the inside, which is just negative 2. So let's simplify that a little bit. We have 2 minus 2x squared, and over here we're going to have minus 4x times 2 minus 2x. So we can factor out 2 minus 2x from both of these. And we're left with a 2 minus 2x from the first one, and we're left with a minus 4x from the second part. So we can combine like terms here, we get 2 minus 6x on the inside. We want to know when these are 0. So here we get 2 minus 2x equals 0. Subtract 2, and then divide by negative 2, we get x equals 1. If 2 minus 6x equals 0, subtract 2 divided by negative 6, x equals 1/3. So we need to figure out which one of these is our maximum. We have 1/3 and 1. The derivative of 0 at those points. If we put in something a little bit smaller than 1/3, so let's say 1/4. 2 minus 2 times 1/4, that'd be 1/2. So 2 minus 1/2, that's going to be positive. And then 6 times 1/4 gives us 3/2. 2 minus 3/2, that's going to be positive. Put something in bigger than 1/3, like 1/2. 2 minus, we'd end up getting 1 here. That's going to be positive. 2 minus 6 times 1/2 is 3. So So 2 minus 3 is going to give us a negative number. That's going to make this negative. And over here, if we go bigger than 1, let's say 2. 2 minus 2 times 2, that's going to be negative. 2 minus 6 times 2, that's going to be negative, so we get a positive. But really, if we look at what our situation is here, this is not going to make any sense for x to be 1. Because what would happen if x is 1? We wouldn't be able to make a box because we'd have 1 and 1. That would make up our whole allotted 2 feet on each side. We'd just be folding it in half. We wouldn't be able to create this shape. So that one wouldn't even be possible. It has to be smaller than 1 in order for us to create a box. So this tells us that our minimum happens when x is 1/3. I'm sorry, our maximum happens when x is 1/3. So let's see what it's asking. It says to find the volume of the largest box. So we don't want to just find like the dimensions. We want to find the actual volume. So our volume is x times 2 minus 2x squared. We're going to take that and plug in 1/3. So 1/3 times 2 minus 2 times 1/3 squared. So on the inside here, we get 2 minus 2/3. So this is like 6/3 minus 2/3. So we have 4/3 being squared. So we get 16 over 9. So our final answer here is 16 over 27. We're talking in feet, so this is cubic feet because that's our volume.